You grade 12, welcome back to my YouTube channel. In this lesson, we'll be dealing with complex number. It's typically an introduction whereby it's a grade 12 technical maths. All right. What actually a complex number? When we're talking about complex number, we're talking about non-real roots. We're talking about we're focusing more of parts of non-real roots. It's when the complex number comes in. What is an unreal root? It's when we have a square root of a negative. If you punch the square root of a negative, your calculator will give you error. Why is that? It's because this is imaginary. It's imaginary. So since this is the square root of -1 does not exist, so the mathematicians tried to figure out what can -1 represent. So they decided to call -1 to become I. -1, they decided to say a negative I just will be equals to what? I, right? Which is what? When you see a negative I, is the same as you see I, whereby this is called this, it's imaginary. We're talking about imaginary units. This is imaginary what? Imaginary units. This is our imaginary unit. They've used this imaginary unit. This is imaginary unit. All right. So this is what we have. Okay. So per se, so since they said this is equals to what? To I. So let us take the square root both sides and figure out something here. So if you take the square root both sides mathematically, take the square root both sides, check, you know, this and this will cancel. We'll have what? -1. This is y is equals to I squared. So we have a second law again. That means, therefore, as you have seen, guys, I squared is equal to what? To -1. Therefore, it's clearly that I squared is equals to what? -1. Are you with me, guys? Where you see, if you see I squared, it's the same as you see what? -1. But when you see the square root of a negative, it's the same as I. But I squared is because we took the square root both sides. We've proven that this and this will cancel. We're left with -1. -1, this is what? It's I squared. So we clearly see that. So we have two things now. We have two things. We've seen that I squared is equals to -1, but the square root of 1 is equals to I. So this is what it's important you're supposed to know. All right. This is very important or crucial. Okay, so guys, let's say now you are given something like this. I raised to the power of what? Of 3. All right. What is I raised to the power of 3? What this will be equals to? All right. So guys, remember, we only know I raised to the power of 2. We know that I raised to the power of 2 is equals to -1. So if you have given this number like this, we have given 3, right? So we have given 3. We have given 3 like this. You can rewrite 3. It's the same as, remember, use your law of exponents. I can be same, write what you know. Start by writing these parts. I raised to the power of 2, because we know I raised to the power of 2. You can rewrite that. Rewrite that as that. You can rewrite it. After you rewrite that, you know this. When you multiply this, multiply by I. Using the laws of exponents, this, guys, it does not change. Remember the law of exponents. If you have x, right, multiplied by x raised to the power of 2, this will simply, the same as what? The bases are the same. We add the exponents. We'll see here is the same as this 1. This will be what? 3. So similarly, similarly similarly to I raised to the power of 2 multiplied by I. This is the same as what? We have not changed anything. You will add the exponents. But however, we know this, guys. We know that we've said this is the same as minus what? Minus 1. Here at the top part. We've seen that. So since we've seen that, guys, we can simply we know that this I squared is the same as minus 1. Multiply by what? By I. We don't. So I is simply equals to what? This will be simply equals to what? Minus 1 multiplied by j by I. So this will be I. Like this will be negative I. You understand? This will be negative I. We'll have negative I. So again, this come. I want you to check and then check. This is 3. 3 it's odd. This is a odd. I want you to check something. I want you to see something, guys. Let me just say I. Then let me write our exponents to become what? Let us write the exponents to become something which is not odd, to become something which is a I can say a I can say that to be what I'm trying to say. Let us try and write something which is like okay. Let me just say 2. 2 is an even. You may ask yourself why we say this is minus 1. We have proven that which is minus 1. So this we know this will be what? I squared will be minus 1. If you don't believe, we know that I alone is equal to what? To the square root of minus 1. You can simply substitute minus 1 here. Where you see when you see j, replace that and square. If you square, you'll notice that the square root and this will cancel. You'll have minus 1. So you can clearly see that I raised to the power of 2 is what? It's minus 1. So you simply go to the straightforward. This will be what? Negative 1. All right, I want you to notice something. I write again even number, even exponents. 4, it's even. If you have 4, remember we know this is a standard thing. You can rewrite that. You can start by say j. I said rewrite this to be j raised to the power of what? Of 2. But this you can know. Since you know, you can also rewrite this. You can also do like this. There's nothing wrong. It's an exponent. Remember, if you have given a raised to the power of c like this is the same. Or if you've given something like this, lots of exponents, to make it simple, let's say you're given x raised to the power of 2, then multiply by 2. This is the same. We multiply the exponent with x raised to the power of 4. So similarly there, we can use that. So guys, there, this is what we have. So but what is minus I raised to the power of 2? This we know this will be minus 1. I raised to the power of 2 is what? Is minus 1. We still have what? Squared to the other side. We still have a squared. So you know when you square a negative value, you simply have what? A positive value. Negative 1 raised to the power of 2. This will simply cover us what? Will give us positive 1. I want you to check something, guys. Let me write again this side. I raised to the power of 5. 5 it's an odd. I want to check when we have odd. I want you to check something. This, you can rewrite this, guys. Start by writing I. Start by 2. There, you write 2. Then you can figure out, then you put your brackets like this. All right. This is the same as what? Times what, guys? The number just before will be times what? Times 2 like this. Again, multiply by what? This will give us 4. Multiply by I. This is simply what? It's up to you which method you want to prefer. But this, you can rewrite this to become this. You start by I, then you write like that. This, if you 4 multiplied by this is 4, but that, so is return back. So I want you to show this will return back, guys. This is same as I raised to the power 4 multiplied by I. If you add the exponents, this will give us what? I5 there raised to the power 5. So this will give us I raised to the power 5. So we have not changed anything. But however, why we did this is because we know this. We know this guy, I raised to the power of what? Of minus 2. This is simply equals to what? To minus 1. But we have our 2 there. You replace that 2 multiplied by what? By I. And then this simply could be equals to what? Positive 1 multiplied by what? By I. But now this will be what? Will be I. So I want you to check something. What have you noticed? Do you notice, guys, if we have the if our exponents, if the exponent is odd, will have what? A imaginary. Our answer at the end must have what? J. It's either is negative J or positive J, but must have what? Must have this J. Our final answer must have a J surely. But if you have your exponent, guys, if your exponent is even number, if you have an even number, let's say just say odd number there. Let me just say odd number. All right. If you have an even number, what have you noticed? Even number, odd number are numbers like 3, 5, 7. Oh no, see 9, or like 11. All those little numbers. When you divide, the number when you divide, you'll have a remainder. But even numbers like 2, 4, 6, 8, going so on. You see the number when you divide, you won't be left with a remainder. It's a number that will have a whole number when you divide. Those are what? Even numbers. So if you have an even number, surely it at your end, if you have an even number, if you have an even exponent, your answer at the end will be 1. It's either negative 1 or positive 1. Notice that at the end we must have something which is 1. Let us check here what we've did before. Check here. You see 2 is what? It's an even. We had what? Minus 1. I've said we'll end up with negative 1 or 1. So let us check this one here. Now we have what? 3. What is 3 there? As you can see, 3 is an odd. If you have an odd, you see our answer we added with what? With the imaginary. We add at the end we'll have what? I. We'll end with imaginary. It's either is negative or positive. Doesn't matter. But check here, guys. We have what? And even exponents. We'll end up having 1. It's either when you have an even. If you have an even, you'll end up with with 1, or you'll have minus 1 at your end. If you have an odd, it's either at your end you'll have minus I, or you'll have positive I at the end of your simplification. All right. So hopefully there you can see what is going on. So hopefully you can see them. So let us try some more questions so that you will see what I'm trying to say. You'll see what I'm saying if there is validity. So let us take a number like 25. Let us take a number like 25. 25i. 25. Yeah, all right. 25, you can see, you cannot, if you divide 25 by 2, you'll have a decimal. So this is simply what an exponent in the 25, it's what? It's odd. I've said when we have an odd, it's either you'll end up with I or minus I. Okay, let us prove that we have I raised to the power 5 or I raised to the power of 25. I've said you start by writing what we know, I raised to the power of 2 always. So to come here, guys, you can multiply this by what? Multiply this by what? 12. 2 multiplied by that. You can write this 12, guys. 12. 2 multiplied by that is what? Is 24. multiply by what again? By I. So this will, this will give us back there. But what is I squared? I squared is minus 1. We have what now? Raised to the power of what? Of positive 12 multiplied by I. So minus 1 raised to the power of 12, that, guys, will give us positive 1 if you punch this on your calculator. Multiply by I. So you see, we ended with what? With I. It's an odd exponent. All right. It's an odd exponent. Are we together there, guys? It's an odd exponent. All right. So this is an odd exponent. It's an odd exponential. All right. So guys, you might so you must be very careful with them. So let us now, you can be given things like the square root of negative 100, and you can be given something like the square root of minus 25. You can say try and simplify this, guys. Try and simplify that. Try and simplify that. All right. You can have that minus 100. You can have something like this, or you can have, so, all right, are we together here? Want us to try this? Let me just see number 3. You can put square root of minus 16. So let's try and simplify this following thing. Let's simplify the following. If you simplify the following, check note is a negative. If you punch this on your calculator, it will give you error. Just know if you have an error, this is what? It's a complex number. Just remember your complex. So this rule in mathematics, you know this rule, guys, that says the square root of A multiplied by B, for argument's sake. This is the same as you take, as long there is a multiplication here, whatever is inside the square root, you take the first will be the square root of what? It's the same as square root of what? Of A multiplied by the square root of what? Of B. Why I am introducing this is because, guys, that on the top, our 100 there, can be same as square root of what? What do we know? Minus 1 multiplied by the square root of what? Of 100. Using this law, minus is inside what? Of the square root. But we know the square root of minus 1. We know the square root of minus 1. We said it's what? It's I. Multiply the square root of 100. We know the square root of 100. You know the square root of 100. You can take the calculator there. If you forgotten the square root of 100, you know that is 10. Then the square root of 100 is simply what? 10. Then if you multiply these twos, multiply these will give what? Yeah, well, it will give you 10i. 10i. Similarly, there we have there number 2. We have the square root of what? Of negative 25. We can use that law. This is the same as square root of minus 1 multiplied by the square root of 25. But the square root of minus 1 is simply what? I. The square root of 5 is what? The square root of 5 is 5. Then when you multiply this will be what? 5i. Will be 5i. All right. There we have 3. Then 3 we have what? The square root. We have given the square root of minus 16. So similarly, this will be the same as square root of minus 1 multiplied by the square root of 16. This is the same as what? Is I multiplied by the square root of what? Of 16. Square root of 16. Square root of 16, we know, guys, is 4. Multiplied by the square root of 16, whereby it's 4. All right. Then this will be what? 4. This will simply same as 4i. Are we together there? Are we together? Are we together? So we know this. You know this now. So if you are given a quadratic, now take a note. You should be careful why this is introduced. You can be given something like this. They can say x, the equation x. They can say solve for x. They can say solve for x, right? Then I just say x is equals to, okay, say x plus 25 is equals to 0. Then I say solve for x. Okay, you'll say x. We know you transpose that will be minus, we'll change the sign, minus 25. Okay, let me do like this. Okay, let me just say x squared plus 25 is equal to 0. Then you say solve for what? For x. Then this will have x squared. When you take that, will be equals to minus 25, isn't it? Then you know you're supposed to do what? To take the square root. Okay, you're going to take the square root and take the square root. They will have x. But boom, when you branch this in your calculator, because there's negative, your calculator will give you what? Error. So remember the complex number. Do not say the question there, the x is, I don't know, x value. No, remember, you have learned about the complex number. This will simply equals to what? But remember, when you're taking the square root, you'll have plus or minus. If you're taking the square root like this, if you have an equation sign, equal sign, because now we're solving. So we have plus or minus what? And the square root of that, the square root of minus 25, isn't it? But we have not done there. So you must know that x would be plus square root of minus 25, or x can be what? Equal to the square root of negative, remember I was supposed of negative square root minus 25. We have 25 there. I'm running out of space there, but okay, let me write it here. So we know, guys, we have talked about this. When you have negative, I said this, you use the law a multiply. It's the same as like we have the square root of a b like this. If I said this is the same as square root of a multiplied by the square root of b, using our sets law. So using that, we can use it that here. So that will be obvious. We have our plus there, but anyway, positive does not affect anything. Even if you don't write the positive, we know it does not affect anything. So you'll have the, if you want, you can write, but positive does not affect anything if you are curious. So this is said this will be same as square root of minus 1, right? Multiply by square root of 25. Again, if you go or you go to this side, x will be the same as what? We have minus 1. All right, we have minus 1 there. Minus 1, obviously the negative must be there. This is the same. If you write negative 25, it will be the same. Okay, here I forgot to put 5. It's the same as minus 1. Multiply, obviously, here. Multiply by 25. So x will be equal to what? This is simply what? I. This will be simply equal to what? 5. Alright, x will be equal to what? Positive 5i. Or we go to this side. This will give us what? I will be I. Our x there is negative. We have what? I. This will same as what? Multiply by what? By 5. The square root of 25. this x will be equals to what? Look what I'm doing there. So okay, this x will be equals to what? To negative 5i. All right, so this is what you have. So take note, this is what you'll have. Please take note of that. So you can be given a form of a quadratic. You can say solve for x, solve for x, given that um, 9, for example, squared plus 6x plus 2 must be equals to 0. Can give you this, then say solve for x. All right, you'll apply your quadratic formula. You know that quadratic formula says minus b plus or minus, all right, the square root of b squared minus 4ac. Divide this by 2a. All right, we have x here minus b. Obviously we'll have b is 6, so we'll have minus 6 plus or minus the square root. B is still 6, but now we square that. Minus 4a, a is 9, multiply by c, c is what? Is positive 2. There, we divide all of this by 2, a is 9, like this. That is what we have there. That is what we have. That is what we have. Still have our x. That is what we have. All right, that is what we have. Let me be careful there. Let me be careful. Okay, let me be careful here, guys. Sorry, initially we've given minus, not positive. Sorry. So that means here we'll have minus b. Here is simply minus b. But anyway, if you substitute minus, won't affect anything. Here this will be minus, like that. Anyway, if you multiply this, simply equal to see minus multiplied by minus will be 6 plus or minus. But when you square negative 6, so it does not affect anything there, guys. So this anyways will still give me what? 36. Then I multiply the inside there. All right, I have 4 multiplied by that, which is 72. All right, divide this 2 multiplied by 9, you're right, which is 18. So we have our x there. So guess what? You'll have your 6 plus or minus. When you try and punch this, do not quickly to put everything onto calculator. Please show step by step, because when you punch on your calculator, if you see error, just know you're dealing with complex. If you punch this, subtract there, you'll have 32 minus 72 will give you negative 36. Aha, as you can see there, under the square root we have a negative. You have negative 30. There we have a negative 36. So obviously we'll have imaginary there. The complex numbers must comes in. The complex number must comes in. So all right, so the complex must comes in. I've shown you how to deal with something like that. So this is 6 plus or minus. I've shown you how to simplify that. That will be same as what, guys? Multiply same as square root of minus 1. Multiply by the square root of 36. This is divide over 6, 8 over 18. I've shown you how to handle that. So here we have 6 plus or minus. This is the square root of what? Of minus 1. We said it's I. The square root of 36 is simply 6, obviously. Multiply by 6. Divide by what? By 18. together. So x, this there will be 6 plus or minus 6i, like this, divided by 18. Right. So if you want here, this rule that says you know this rule that says a plus b over c is equal, you divide the first one by x, also divide the other one b plus c, so by c, so you can use that 6, this will equal to 6 divided by 18 plus or minus, divide that 6i divided by 18. So this will simply give us what? 1 over 3 plus or minus I 1 over 2, or let me just not write it clear, it will be simply equals to 1 over 3i. So this is what we have so far, guys. In this typical question, this is what we'll have, guys. This is what we'll have. So anyway, thank you for watching, guys. We'll end here. Thank you for watching, and may you kindly subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. Feel free to like and to comment and to share this to your fellow classmates. All the best. Thank you for your time.